Hello, hello. So this is going to be the answer key for K3. A couple of things to touch on before we do that is the idea of what a central angle is and what an arc is. So a central angle is going to be an angle formed inside of a circle where the center is the vertex of the angle. Remember, the vertex is the point of the angle, so that's located at the dead center of the circle. So this central angle corresponds with what is called the arc of the circle. In this case, this is going to be the minor arc of the circle because it's less than half of the circle. It's less than 180 degrees. While this is the minor arc, more than 180 degrees is the major arc, okay? Arc addition postulate functions the same way as angle addition and segment addition. It's just saying that when I combine two arcs together, so arc AB plus arc BC equals arc AC. That's really all it is. It's taking pieces and adding them together to create a whole. Now, what we need to remember is that when it comes to a circle, a full circle is 360 degrees, which means that half of a circle is worth 180 degrees. Okay, so when I have a diameter drawn in, a diameter is technically a straight angle. So that straight angle is going to be worth the same as the arc that it creates. So it's equal to that half semicircle 180 degree angle. Same thing is true on this side. All of this makes up 180 of the full circle, so I can use that to my advantage in order to find the arcs that they're asking for. So to find the measure of arc HJ, I know that I can look, to find arc HJ, I can look to the central angle that created it. If that central angle is 63 degrees, then that arc is 63 degrees. For arc FGH, so that was arc HJ, for arc FGH, they're using 3 letters, which means they're talking about a, whatever. They're saying that the ends of the arc are going to be F and H, and it passes through G in order to get to that other point. So we're looking for this whole arc. In order to look at that whole arc, I need to know this whole angle. So if all 3 of these together make up a full semicircle, that means if I subtract that 63 from the full 180, I should find that from here to here, this entire angle is worth 117 degrees, which means this arc is worth 117 degrees. Okay, next question. Number 3, looking for arc CDE. Again, it's going from C to E by passing through D. So we're looking for this whole thing here. Some things that we can keep in mind are we have a 90 degree angle here because of this box, so I know I can account for 90 degrees there. Something you can also remember from actually Unit A, all the way back in the beginning of the school year, is that we have vertical angles here. We have 2 lines forming an X, so if this is 40 degrees, I know this is 40 degrees. Vertical angles are always congruent, and now I realize that this 90 degrees plus this 40 degrees is what makes up arc CDE. So the measure of that is going to be a total of 130 degrees. Next, we're looking for the measure of arc BCD. So it's going from, let me erase all of this. Okay, so this time we're going from B to D by passing through C. So we already said this was 90. And now if I realize that this is a semicircle, this is half the circle, I know that all 3 of these angles should add up to 180. So if I subtract the 90 and the 40 from 180, I find that this guy here is worth 50. So these 2 combined get us a total of 140 degrees. Okay, number 5. Measure of arc LMN. L to N by passing through M. That's the arc we're looking for. We know that one's 30. We know this is 105. We can see that we have a semicircle here. So I'm going to do similar to what we did up here on question 4. I'm going to subtract the 105 and the 30 from 180. And that tells me that this angle here is 45 degrees. So when I combine the 30 and the 45, I know that this arc is worth 75 degrees. Arc LNP, so going from L to P by passing through N. I want to figure out what all of that combined is. We can, nope, not to, yeah, I guess so. So I have a couple of options here. I can acknowledge that we technically do have vertical angles. The combination of these two should equal that whole unknown angle, which makes that 150 degrees. We can also go down the road of, okay, if I go down that road, I know that this entire arc is 150 plus the 30 plus the 45 to get us 225 degrees. I could have also gone down the road of saying if this one's 30 and these are vertical angles, then that one's 30. And I can take the total circles 360 and subtract out the only two arcs that are not included in the arc that we're working with. So I'm going to subtract out this 105 and this 30, and I should get 225, right? 360 minus 105 minus 30, 225. Next page. This one's referring to this concept here. We're going to have congruent, okay, so if we have congruent central angles, so let's start there. If I know these central angles are congruent, then I immediately should know that that makes the chords that they create congruent. If I have congruent chords, this is kind of like a chain reaction thing, then I know that the arcs formed are also congruent. And then, in a sense, the reverse is true. If arc BA is congruent to arc CD, then that means these angles are congruent. So everything kind of goes together. All the pieces lead into one another. This part down here, I'm allowing you to eliminate so you can ignore that. So using this whole idea, they're showing me two congruent chords. That means that my arcs are going to be congruent. So I set up that equation, 3x plus 22 equals 4x. Subtract 3x from both sides to get 22 equals 1x, which means we're almost done. Finding x is important, but in order to find the measure of arc QR, I have to plug it back in. So arc QR, the measure of arc QR, is equal to 3 times 22 plus 22. Come on. Okay, so the measure of arc QR equals 88 degrees. Number 8. This time they're showing us that we have congruent angles, and then they want us to compare those chords. Well, I know the chords are going to be congruent because the central angles are congruent. So 2y plus 5 equals y plus 13. Subtract 1y from both sides to get 1y plus 5 is equal to 13. Subtract 5 from both sides to get that y equals 8. Again, we're almost done, but ultimately they're asking for us to find, just find the length of segment GH. And GH is equal to 2 times y, which is 8, plus 5. So we have 16 plus 5, 21. Oh, not degrees, just 21. Sorry, angles and arcs are in degrees, that segment measure is not.